too fancy there. Alternating series test, actually, if it's alternating, you can almost see the answer. By the way, if it's increasing, chances are that limit's not going to go to 0. Those two really go hand in hand. So let's test for absolute convergence. Absolute value just kind of tosses that alternating part. What do we know about this series? This is divergent. This is not harmonic series, right? So is this original one absolutely convergent? No, because we took the absolute value, ran a test, any test. In this case, it's just a harmonic or p-series. And it was divergent. So according to the definition of conditional convergence, it says given a series, it's conditionally convergent if the absolute value piece is divergent, but the original one is convergent. So what would we conclude in this case? Conditionally convergent. So from now on, every test that we run, we can no longer just say convergent. We have to now say it's either conditionally or absolutely convergent. Again, the nice thing is, anything with a star, we don't have to run another test. If it's convergent with the one with the star, all the terms have to be positive anyway, so the absolute value becomes irrelevant. Everybody get that? Come back to that. Jump ahead if we want to. So let's say let's answer. Those will be my second example. So here we have summation of -1 to the n power over 1 plus n squared. What I could do is run the alternating series test. Sorry, I was blanking for a second. Run the alternating series test, but let's say I want to skip to the chase. I think it's going to be convergent. So I'm going to risk it. I'm just going to take the absolute value and go. Because if I take the absolute value and run one test and it's convergent, absolutely convergent. I don't have to do anything else. If I take the absolute value and I run a test, and it's not convergent, that leaves me two options. It's either conditionally convergent, or it's divergent. Right? I can't conclude anything. So I'm going to risk it. I'm going to take a chance, and I'm going to try for absolute convergence. This is what I mean by it's not a test. It's sort of a risk. Let's give it a shot. Let's take the absolute value and go. See what happens. I'm going to give you a few moments and see if you can figure out if this series here, with the non-alternating part, we take the absolute value, is convergent or divergent, and you have to use a test. You can't just guess. So actually run the test properly.
one are you doing?
I'm seeing a couple of different ways to do this one. Which test do you think you're going to run?
Doesn't limit comparison.
Okay,
That's what I was thinking.
That was good. So you could do integral test, that's fine. You could do a comparison test, that's fine too.
Yeah, I think limit comparison.
Either way is fine. In fact, maybe one of you do one test, the other one do the other.
Integral is longer.
Yeah, I'd be like, nuts.
What are you doing on Sunday? What are you doing on Sunday?
Sunday? Probably hang out with a friend. And I gotta help my other friend with the that show he's gonna have next Friday.
Oh, yeah. Is it next Friday? Shit. I'm so distracted by that. Like, the fact that happened. It was so emotional for him to, like, get rid of that dog. It was just so much. It's just like...
Wow. It was like, he was ready to say goodbye and everything.
He did. I mean, like, he fucking handled it. It's just...
That's so messed up.
Bless you. Tell me what you just did. Took the limit.
I took the limit of the comparative. And then, so, yeah. Original divided by the one you're comparing.
The one that you want, yeah.
And then it came out to be n over 1 plus n squared, or n squared plus n squared. And when you have, two things with the same exponent.
Same power?
Yeah, same power. You take the number in front of it.
The constant.
That will be the number, the answer to the limit.
Okay.
If it involves infinity.
Okay. Or my Christmas songs. Like fun.
Convergent or divergent? What do you think?
Convergent.
Convergent.
I'm thinking convergent. Using either test, right? So if you compare this to 1 over n squared, which is convergent, the summation over n squared, which is convergent, and then you do the limit comparison or the direct comparison. In both cases, you're going to get convergent. What does integral test give you? Yeah.
It would be 5 by 2 minus 5 by 4.
Yeah, 5 over 4. Good. So you have to say that it's, what are the conditions? The term's not going to be positive, it's going to be decreasing, it's going to be continuous, right? After you change to f. Either way, this is convergence. What can we conclude then? Do I need to run the alternating series test? No, I skipped the whole test I didn't need to run. I took the absolute value, I took a chance, and it paid off.
Talk to me at the break. Help me.
How we doing?
I'm gonna give you a flyer later. Because we have like 2 weeks to find out whether he's going to shelter.
Oh man, that sucks.
Yeah, we don't have anywhere else for him. He's a really, really good dog. It's stressing me the fuck out right now. I almost didn't come. I was already parked when I was hearing about all this shit too, like trying to deal with it.
Please take a moment. And take a chance on this one. I want you to go ahead and try perhaps with convergence by taking the absolute value right away and see what happens. For 2.5 hours next Thursday night, this is all you'll be doing.
What other project?
Exactly this.
Yep.
You'll have a mere 11 options. I love this chat. This stuff's so cool. You have no idea what's coming.
Geek out, watch out. What are you doing? Tell me everything.
Taking the absolute value.
I think we only have 3 sections after this. 3 new sections.
That's right.
Section 7 is not a new section, so. Again, for this one, you have the option of the integral test or a comparison test.